Welcome to this explainer. Today, we're diving into what I think is one of the absolute coolest mysteries in human history. I want you to imagine a rock that just sat in the ground for, about 4 billion years. It was dull, reddish-brown, heavy, and honestly, completely unremarkable. Farmers stepped right over it. Builders used it to just fill random gaps in walls, and literally nobody looked twice at it because, well, it just looked like dirt. But buried inside that completely ignored rock was the exact material that would one day hold up the tallest skyscrapers, form the hulls of massive ocean-crossing ships, and literally build the modern world.
So we have to ask ourselves, how on earth did ancient humans invent steel without knowing any chemistry? Let's dive right into this because the absurdity of this story is just wild. The real mystery isn't just how we found iron. The much deeper question is how ancient people with absolutely no chemistry, no periodic table, no universities, no traditions to fall back on, could look at a dull red stone and, through fire and probably 10,000 failed attempts, accidentally invent the foundational metal of our entire civilization. I mean, they had Stone Age technology. They had absolutely zero business producing steel.
And you know what the craziest irony of this whole era is? Iron is the fourth most abundant element on Earth. It makes up more than 5% of the Earth's crust. So, it was quite literally everywhere beneath the feet of ancient builders who were putting up the pyramids and writing down the first laws. But they couldn't do a single useful thing with it. Why? Well, because over geological timescales, iron reacts with oxygen. Almost all of it had rusted into iron oxide. It didn't look like a shiny metal, it just looked like, red dirt.
Section 1. The Bronze Age Bottleneck. A logistical nightmare. So, for about 2,000 years, human civilization basically ran on bronze. And bronze is fantastic, right? It's tough, it holds a great edge, but there's a huge catch. It requires a highly specific 9-to-1 mix of copper and tin. And here is the fatal flaw in that recipe. Copper was everywhere, but tin was incredibly rare. For massive empires in Egypt or Mesopotamia, just getting tin meant relying on these incredibly fragile, continent-spanning trade networks. They were hauling tin all the way from places like ancient Cornwall or Afghanistan. Think about that. A single war or even just a really bad storm could literally bankrupt an entire empire of its most important tool.
Section 2. Metal from the sky. Alien iron.
Now, there was one exception, and we call it sky metal. These were native metallic iron fragments from actual meteorites, and they were naturally alloyed with just a little bit of nickel. When these hit the Earth, they brought pure, ready-to-use iron. And ancient cultures independently realized that this stuff was utterly alien. Egyptian scribes literally named it metal from heaven. We've actually found Egyptian beads from 3200 BCE, and even King Tut's famous dagger, both hammered entirely from meteorites. So long before they could actually smelt iron, they were forging weapons out of literal space rocks. How cool is that?
Because it literally only came from falling stars, this sky metal was unbelievably rare and prized. In fact, ancient Assyrian trade records show that meteoric iron was priced at 40 times the value of silver by weight. Yep, 40 times. It was way rarer and much more valuable than gold. This was a metal reserved strictly for kings. It was treated as a top-tier diplomatic gift and the ultimate symbol of power.
This really highlights the massive engineering wall our ancestors hit. See, bronze melts at about 950 degrees Celsius, but pure iron, that requires 1538 degrees. That roughly 400-degree gap was a fatal paradox. Bronze Age kilns physically could not get hot enough to liquefy iron. If they threw iron ore into their copper furnaces, absolutely nothing happened. The rock just sat there glowing red, which of course just reinforced everyone's belief that it was totally useless.
But over generations, metalworkers slowly started making these tiny, incremental improvements to their kilns. They swapped out raw wood for charcoal, because that burns hotter. Then, they built enclosed clay shafts to create this sort of chimney effect. Eventually, they added leather bellows to manually pump in extra oxygen. Now keep in mind, they were doing all of this just to melt copper more efficiently. They weren't trying to invent iron. But inadvertently, they were building a machine capable of something completely revolutionary.
Section 3. The accidental chemistry, a miraculous reaction.
These animated steps here really help us visualize this totally invisible solid-state reduction process. So, inside that enclosed furnace, the burning charcoal doesn't actually have quite enough oxygen. Because of that, it produces carbon monoxide gas. And as that gas rises up, it chemically strips the oxygen right out of the iron ore. The absolutely mind-blowing part about this? The iron never actually melts, not once. The gas just chemically transforms it from a rock into a metal right there in its solid state.
So imagine the utter confusion of the first ancient smelter who opened up the bottom of their furnace. They were expecting a pool of liquid, copper, right? Instead, they pulled out this dark, porous, weird-looking sponge of metal and glassy slag. We call it a bloom. It didn't shine, it honestly looked like garbage, but when they hit it with a hammer while it was still hot, it didn't shatter like a rock would. It deformed. It bent. They had a completely new material in their hands.
Section 4. The Secret of Steel. Forging the Future.
And this is exactly where the blacksmith comes in. Taking that white-hot sponge at around 1,000 degrees Celsius, they literally beat the impurities out of it using heavy hammers. This intense, brute physical force squeezes out the liquid slag and forces the metallic iron particles to fuse together at the atomic level. It's a process we now call solid-state diffusion welding. Through sheer observation and a lot of muscle, they managed to create tough, bendable, wrought iron.
But here is the crucial point: how they accidentally discovered steel. Blacksmiths started to notice that if they left the iron sitting in the hot, burning charcoal for hours, it fundamentally changed. The iron was actually absorbing carbon atoms from the charcoal directly into its crystal structure. This is a process called carburization. When they took that carbon-infused iron and rapidly cooled it, or quenched it, in water, it locked into a super rigid structure called martensite. Without knowing any of the underlying chemistry, they had just created a steel edge 2 to 3 times harder than bronze.
Section 5. The Tin Crisis. Adapt or die.
Then, right around 1200 BCE, global geopolitics shifted violently. The mysterious late Bronze Age collapse completely destroyed those fragile continent-spanning trade networks we talked about earlier. The global tin supply basically evaporated overnight. Civilizations were left with a brutal choice: adapt or die. Because iron ore was literally everywhere and, crucially, didn't require imported tin, they were forced to adopt iron out of sheer survival.
And you know what this resulted in? The ultimate democratization of metal. Because iron was so cheap and locally abundant, it wasn't just for kings and elites anymore. Suddenly, an ordinary peasant farmer could own an iron plow that dug deeper into the soil and produced way more food. A common soldier could be fully equipped with an iron weapon. This shift fundamentally moved power and productivity away from the palace elites and distributed it directly into the hands of everyday people. It was a total game changer.
Section 6. Global Innovation. Independent Paths.
Now, it's really important to know there was no single inventor of iron. In China, they engineered blast furnaces so incredibly hot that they actually did melt the iron, creating cast iron, and they were even using water wheels to power their bellows by the year 31 CE. Over in India, metallurgists used clay crucibles to fire high-carbon woot steel, which you might know better by its later name, Damascus steel. And in sub-Saharan Africa, engineers built these massive, tall, natural draft furnaces that preheated the air, achieving just incredible thermodynamic efficiencies. Human ingenuity was popping up everywhere completely independently.
Section 7. Building the Modern World. Scaling up.
Of course, scaling this whole process up took centuries. It really wasn't until 1856 that an innovator named Henry Bessemer truly cracked the code for mass production. By blasting cold air right through molten pig iron in his Bessemer converter, he was able to burn off the impurities in minutes without needing extra fuel. That single innovation made cheap, massive structural steel economically viable. Suddenly, building railways that connected entire continents and skyscrapers that touched the clouds was actually possible.
I really want you to think about this for a second. Every single piece of steel you see today, the steel beams inside your building, the frame of the car you drive, it all relies on the exact same chemical accident observed by an ancient copper smelter thousands of years ago. We just scaled it up by a factor of millions. The carbon monoxide in a modern factory still strips the oxygen from the iron oxide, exactly the same way it did in a little clay pot on an ancient hillside.
Which brings us to a final, provocative thought to take away from this explainer today. For millennia, humanity walked right over iron ore, completely convinced it was just useless red dirt. So what seemingly ordinary, completely overlooked material is sitting right beneath our feet today? What is currently being completely ignored, just waiting for the exact right accident to define the next great chapter of human civilization?